The auditory system. The auditory system description and function of outer, inner, middle, inner ear, basilar membrane, inner hair cells, outer hair cells, auditory filters, phase logging, envelope and fine structure, sources of hearing loss. So the ear can be divided by three parts: outer ear, middle ear, and inner ear. The outer ear is the acoustic system with the pinna and concha and the ear channel and the eardrums. It's an acoustic system where the sounds come in. The middle ear is a kind of part of the mechanical system with the ossicles, those three small bones, and Eustachian tube, balance tube, you can say. It's a mechanical system, and from the eardrum, from the sound, the eardrums are oscillating, and then the ossicles are moving, and then there is between the middle ear and inner ear, there is oscillating, vibrating. There are some basilar membrane in the cochlea, which is oscillating and transfers the frequencies to distant points on the basilar membrane. Also, so-called frequency selectivity is going on. Complicated, but and because of the pressure is the force divided by area, and the eardrums area is much bigger than the oral area when the staples are touching, connected with the inner with the cochlea. So there is a what's called impedance mismatch. So yeah, all okay, and then the because of the oscillations of the membrane, there are some inner hair cells moving. They're moving when some stereocilias are moving in a certain direction to the right. Then there is some transmitter going on to the through the synapses to the neurons or the auditory nerves, and then it stops when they are turning to the left. It's turning, then it stops. It can be called a rectifier. Yeah. And you have the outer ear. Okay, you have the outer ear I have talked about. There's some head-related transfer function. Sound we are arriving at ear is affected by torso, head, and pinna. The head-related transfer function is measure gain between sound intensity at ear channel entrance versus free field with no head. What does it mean? What means that there are some torso, head, and pinna? It will gain the dB sounding compared with the free field. We have the ear cannon, crooked about 2.5 centimeter, and it protects the tympanic membrane eardrum with earwax to collect or remove dirt. Some earwax is a tube that is open at one end and closed at the other. And because of that, you can say that you can find out the resonance, the so-called resonance of ear channel, because the wavelength divided by 4 is 2.5 centimeter. That means that the wavelength is 10 centimeter. And the frequency is the sound speed divided by the wavelength, and that gives a frequency, if you can calculate, about 3,400 hertz. So you can say there's a volume velocity is zero at the end, at the closed end, and as a zero and maximum, and amplitude is maximum at the open end. It's opposite to pressure. Pressure is maximum at the closed end and minimum at the open end. Ear channel resonance, as I talked about, there's also a concha resonance about 5 to 6 kilohertz because this head related transfer and boost of more than 10 dBs around 1 to 7 kilohertz as a boost. Yeah, also. Yes, so yeah, it makes totally 20, maximum 20 dBs more. You have a tympanic membrane, and yeah, it's very thin. The square is 1 square centimeter, the area about that, thickness 0.1 millimeter, small mass, and then its displacement at about threshold 120 dBs is 0.1 millimeter. You can also say you can also calculate when it's 0.1 millimeter displacement at adherence ratio. What is it at zero? It's about 120 decibel SPL. What is it about sound silence? About 0 decibel SPL. Turns out that it's times the displacement is time 10 raised to minus 10 meter. Yeah, it's a simple calculation. 120 is 20 times log P2 divided by P1, and that means that at this log 10 P2 divided by P1 is 6, and then the P2 divided by 1 is 10 or raised to 6. Yeah. Why have a middle ear? Yeah, ossicles, smallest bones in the body, malleus, a hammer, and the anvil, hammer, anvil, and the stirrup. I talked about before that there's impedance matching going on. The area of the stapes of tympanic versus stapes, it gives a pressure enhance lever. P divided pressure is force divided by area. Eustachian tube in the middle ear. Eustachian it connects middle ear activity to some to the narrow nasopharynx. What is it there? It uses to equalize pressure to middle ear and outer ear. For instance, when you are flying, ears pops when Eustachian tube opens. Pops. Okay, and so some equalizing between pressure, inner and outer pressure. Middle ear and outer ear. Okay. Middle ear reflects when muscles are connected. Transmission is reduced by 20 dBs. When muscles, okay. Well, there are some muscles if the sound exposure, or also because the speed as transmission is reduced by 20 dBs. There's some delay, and that means that the sound comes to the inner ear, to the brainstem, and then the muscle reduction of audibility of own vocalization or protecting. But then in the last case, the muscles are working about more than 70 dBs SPL. But sudden explosion or sudden exposure of sound, it cannot prevent damages. What is the inner ear? It's cochlea. The inner ear is in skull. The inner ear consists of two parts: cochlea related to hearing, and semicircular related to sense of balance. Now, the last one is also very balance important, but we are talking here in this course about the cochlea. The cochlea is U-shaped, 3.5 centimeter long, 2.5 turns, and you have some in the cochlea. There are some the important things is going on. You can say there's a organ of Corti, and we have we have three spaces with liquid with scala vestibular, scala media, and scala tympani. And this basilar membrane is situated between media and tympani. You have some organ of Corti, it consists of inner hair cells, outer hair cells, and the so-called tectorial membrane, which is in touch with the outer hair cells. There are some staphylococcus touching this tectorial membrane. And the hair cells, they are cells with stereocilia. Outer hair cells, most often about 12,000 in 3 rows, and they are in contact with this tectorial membrane in the organ of Corti. Inner hair cells, it's single row about 3,000. I can say a little bit about hearing loss. A cochlear hearing loss is inside as a inner ear loss, hearing loss, often involves a course of outer or inner hair cells, stereocilia. It means inner hair, outer or inner hair. Loss of outer or inner hair cells because of noise exposure, age, genetics, and maybe some chemicals, ototoxic chemicals. How does it work? If, for instance, you have some frequency, sound frequency, about let's say 2 milliseconds, a period with 2 milliseconds. There's a frequency about 500 hertz. There's a certain place on the basilar membrane that oscillates. And complicated stuff is those liquids in the vestibulars get under pressure. The basilar membrane oscillates. I'm not very specific about this. And also tonotopy, if you have a mixed sound with more than one frequency, then the high frequencies and the low frequencies they are impact the basilar membrane different places. The high frequencies is near the base, at the base near the oval window, where the basilar membrane is narrow, and the high low frequencies is near the apex. To these sounds or tonotopy, there's you can say an aid here. We called auditory filter bank. Auditory filters have some center frequencies. There's a sound, certain specific sound tone has a certain frequency, and your bigger center frequency, your broader are the filter banks, the auditory filters, and those auditory filters can explain things. There's a tool, you can say, engineering tool. It can explain what's called excitation patterns and so on. Okay, that was part 1.